Hola! Welcome back. We have one more trend to talk about, and that is ionization energy. Now, when you think about ionization, you think about ions. Remember that ions are just charged particles. They've either lost or gained an electron. So when we're talking about ionization energy, we are talking about the energy needed to remove an electron. Now, we can remove more than one electron most of the time. And when we're talking about this energy, it gets harder to remove more than one electron. Remember that when we're looking at the atom, all those electrons, they like those protons. So if we're taking electrons away, it kind of pisses those protons off. They like the electrons. They like to have them around. So if we get rid of one, those protons hold on to those electrons even tighter. So it may take a little bit of energy to take away the first electron. All right. But when we start trying to take away the second electron, and when we start trying to take away the third electron, those protons aren't going to have it. They hold on tighter and they don't let them go. So the more energy is needed to remove more electrons. Now, as we're looking at the trend here, as we're going across the periodic table, so our trend in going across, remember that over here, everybody wants to be a noble gas. The kings of the periodic table, everybody wants to look like these guys. So these elements are very close, again, to becoming noble. If we were to take away an electron from them, they would go the wrong way. They would look more like oxygen. Fluorine, if we took away an electron, would look more like oxygen. If we took away oxygen's electron, it would look more like nitrogen. That is going the wrong direction. It's like running the wrong way in a race. They want to go that way. So these elements are going to hold on really tight to those electrons. They do not want to get rid of them because they are so close to being noble. Over here, however, these elements, like we said before with electronegativity, they're the cheaters. They would much rather lose an electron because then they could go backwards and look like the noble gases. If lithium loses an electron, it's going to look like helium. Looks like a noble gas. So the energy needed to take these away isn't going to be very much. They're giving them away. They're like, here, take my electrons, because then I'm noble. So low energy on this side, high energy on this side. So as we go across, ionization energy increases. Now as we go down these groups, remember these are smaller and these are larger. Now think about electrons like a candy bar. Now I like me some chocolate. And so if I have a candy bar and I'm really small, I'm holding it close to my body. If I'm really big and they're like electrons, they're way out there. Okay? What's going to be easier for you to steal from me? A candy bar that I'm holding really close or a candy bar that I'm holding way out there? Well, duh. It's going to be easy to steal something from way out there. Same thing with these. They're holding their electrons way out there. These are those large atoms. Their electrons are clear out here, far away from the protons that are holding them. So it's going to be really easy to steal one of those. It's not going to take as much energy because they're way out there. These guys, however, their electrons are really close to the protons. That means those protons are holding on really tight. So it's going to take a lot more energy to steal one of these guys than it is to steal one of these electrons. So as we go down, the ionization energy decreases. More energy to steal from the smaller ones. Less energy to steal from the larger ones. All right, that's all for today. I will see you next time.